Now let's see the some proximity methods that will help us to compute the proximity value between two different clusters. Okay, and there have also some advantage and some limitations. Let's see these things one by one. Okay, so the proximity methods that we in general used to compute the proximity value between the two different clusters are the methods are like this. So mainly these methods we have applied. First one is the mean method, that we call the mean method. We will see these things step by step through examples. The first, write down the different type of methods first. So first one is mean method, second one is the max method, third is the group average method, fourth one is the distance between the centroid method, distance between centroids, the fifth one is the others method driven by objective functions, means others method that's depend on our requirement. Okay, means simple, it's driven by an objective function, means the what kind of objective we have, that's depends on this. By n driven by an objective function. Okay, mainly these 5 kind of methods we will use to calculate the proximity value. Okay, now let's try to understand each one by one. Okay, so first one is the mean one. First one is the mean proximity. First one is the mean. How we will use this mean concept to compute the proximity value. Sure. The mean was suppose let's the data set we have. It's better if we just discuss this concept to an example. Suppose let's take the data set that we have like that. This is the data set. These are the data sets that suppose let's take the data. Let's take the data. Here is P1. This is the P1. This is P2. This is P3. This is P4. Let's take this is P5, P6, P7, P8, and P9. This data we have. Suppose let after some calculations we make this is a single cluster. This is a cluster, and this is a single cluster. After some iterations we make this. Now after these iterations, at the end of these iterations, at the end of the day, we have to calculate this distance value, means this proximity value. Proximity means I am talking about simple. The proximity means proximity. Just we don't confuse. Proximity means the kernel value. Kernel value. Already we have seen the concept. We have learned the concept of kernel in logistic regression chapter. Means the kernel value that I am talking about. Kernel value means in sense of similarity or distance. In sense of similarity value or the distance value. I am talking about these two types. Okay. Suppose at the end of some iterations, we have to compute this proximity value between these two clusters. Suppose let's take this is the cluster 1, this is the cluster 2. Okay, add up the end of the day, we have to calculate it. Now, how? By using simple the mean concept, how we will compute it, this proximity. So the thing, that concept here, we have to compute it, the distance between edge point, means distance means similarity between edge points, similarity or distance, as you can treat similarity. Suppose let's take for some time, we will use the similarity between the edge point. It's the easy task, we can easily compute it, similarity or distance between the edge point, easily we can compute it. Now between this similarity, we have to choose the minimum one. What will be the minimum distance? Okay, suppose let's take the among all the similarity, the minimum value will be here, this one. Suppose let's take the minimum value will be this one, these two, between these two points, the minimum value among all the distances, this will be the minimum. Let show the mathematical formula of this. It will be, now the mathematical formula, the similarity, suppose let's take the similarity between the cluster C1 and the cluster C2. It will be, first we have to compute it, the similarity between the H pair of points, means EI, EJ, H pair of points. Now among all these pair of points, we have to compute it, the minimum one. We have to compute it, the minimum one, where our PI is belongs to the cluster C1, the PJ that will be our belongs to our cluster C2. That's the thing we have to use. That's the calculations, that's the mathematics we have to use to compute this proximity value. This will be the proximity value between the cluster C1 and cluster. I think you got the idea how using this mean concept, how we will compute this thing. Now let's discuss the max concept. How we will compute the proximity value by using the max concept. Now let's discuss this max concept. So the same examples I have here taken, the same kind of, suppose let's take this is point, this is, and this these are our data set. Let's take the same kind of data we have taken also. Suppose let it is the, suppose we name the same name, E1, E2, E3, E4, E5, E6, E7, E8, E9. E9, I think I've taken here 4.1, 2, 3, 4, 5, 4. I've taken here, sorry, I have doing some mistake. 5, 6, 7, 8, 9. 5, 6, 7. Okay, 5, 6, 7, 8. Take an average. Sorry, it will be 9. Sorry for. Okay, these are the, suppose let these are the points that we have. So, clusters, after some iteration, suppose let's take these points are make some cluster, and these points make some cluster. After some iteration, so let it is a cluster C1, now cluster C2. Now using the max concept, since the same things also applicable here, first you have to compute the similarity or distance value between two different pair of points, okay, on two different clusters, and we have to find the maximum distance value. What will be the maximum one? And we have to choose this. Okay, that's the choose this value. What will be the maximum one? And we have to choose this maximum value between. So here, what will be the maximum? What will be the approximate value? The maximum here will be this value. This will be the maximum value between two clusters. So these things are the minimum, and these things are simple the maximum. Okay, So now the proximity value. Now the proximity value here will be the cluster 1 and cluster 2. This value now it will be, the formula will be what? Same formulas. First we have to compute the similarity between each pair of points Pi, Pj. Now we have to compute it. Now we have to compute different pair of points. Now in this set we have to take the maximum one. We have to take the maximum one. In what basis? Where Pi will belongs to the cluster 1 and Pj it belongs to the cluster 2. Okay, I think you got the idea. What is the difference between the mean concept and max concept? Same thing, just instead of using the mean, here we will use the max. Okay, now let's discuss the third concept, group average concept. How these things are applied. Now let's take our concept, the group average. The group average concept. How these things we have to apply to compute the proximity value into different classes. Okay, now let's see. Now the group average, this formula. Just draw the picture first. The same type of picture. Suppose let's draw it first. These are the 5 points. These are these 4 points we have. So first rename it. P1, P2, P3, P4, P5, 6, P7, P8, P9. These are the 9 points in our data set. So after some iterations, let these 5 points make a single cluster and these 4 points make a single cluster after some iteration. Okay, now the questions, how will compute the proximity value by using the group average concept? The concept is the same. First, the same things also have to apply here. First, we have to compute the distances between each pair of points, and to compute the proximity value, we have to take its average value. Instead of using the minimum or maximums, here we have to take the average value. First, we have to compute the each pair of distance. To compute the each pair of distance for each value, similarly for here, 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 for this point also. Okay, like that, like this each pair of value. Each pair of value we have to compute it first. So after computing it, the average formula, the similarity between the two clusters, suppose cluster 1, this is the cluster 2. Now the similarity value between these two clusters C1 and C2, this value now it will be we have to compute the average one. First we have to compute the similarity value between two pair of points Pi and Pj. Between two pair of points we have to compute it. Now first we have to make it, means we have to compute this average of this. First we have to compute its summation, summed value for what basis? The Pi, the point Pi, it will be lie on the cluster C1, and Pj, it will be lie on the cluster C2. Now after compute it, we have to make its average, means we have to divide it by using the summed value. means the number of data points this on that set, means the number of data point on the class, the number of data points on the cluster set. Okay, and see these things means what? These things means the size of C1s means number of data points in C1 or size of C1. As you similarly for here also, this is the size of C2. This is the thing that we have to calculate the proximity value between two different clusters by using the group average. This simple, we have to use the concept of mean. Okay, I think you understand. Now let's come to the fourth one, distance between the two centroids. How will compute this thing? Distance between the two centroids. Okay, how will compute it? So the fourth concept is the distance between two centroids. Distance between centroids. Using this concept, we have to make the using this centroid distance, the distance of the two centroids, we have to make this value. So this value will be now this value will be the similarity. So let's draw the same picture again. I think it's better. It will be better to understand. Draw the same picture. So let's take these are the picture. These are the data points that we have. These are the suppose let these are the data points. These 4 data points. Make some after some iteration. These data points make some clusters, and these are the some cluster. These are the some cluster. Now first that we have to compute is what will be the centroid. Suppose let's take using some technique of the centroid, we find these are the centroid, and here these are the centroid. We already see how to compute the centroids. By simple, you can using the mean concept on into intra-cluster distance. Using the mean of the intra-cluster distance, we can compute the centroid. But the disadvantage is that sometimes the centroid may not lie on this cluster point on our data set. Suppose let's take the centroid, it has small c1, the small c2. Now on these distances, we have to compute this distance between two centroids to compute its distances. Okay, so the drawback is its drawback is sometimes is may not lie on the on this data point. The main drawback is the main drawback of this clustering technique is sometime using sometime, so the centroids may not be in the data set, may not be in your data set. That's the main drawback. If this is not our in data set, then sometimes it is not possible to interpret this. In K-means chapters, we will already see. Now the fifth one is that we have the others methods, means that's depend on our requirement. What kind of requirement, what kind of similarity we have what kind of accuracy we need. That's the depends. Means in such cases we have to make the objective functions as our requirement. So I am not discuss this fifth cases. When we discuss the case study, when we discuss the projects of using it, we will see how to using this kind of objective function. Okay, now in generally these are the general methods that we have used to compute the proximity value. So there have some also or as well as there have some limitations, as also there have some advantage. Now let's see these things. So what kind of limitations have there have and what kind of advantage they have for edge method. Okay, for edge proximity method. Now let's see these things through an example. Let's see. Now let's see what is the strength and what is the limitations of the edge proximity method that we have already discussed. So the first technique that we have discussed, the mean method. Okay, already we have seen. So let's see what is the strength and what is the its limitations. So the matrix you have seen here, this is the proximity matrix. This is the proximity matrix. Just in previous, just at the beginning of this lecture, we have see how to calculate this proximity value. Now, based on this proximity value, let's see. So first we have to find the minimum one on this proximity value. So what is the minimum value on this proximity matrix? Let's see. So the minimum value, if you just closely look up, this minimum value is now 0.11. These are the 0.11 is the minimum value among all the value of this matrix. Okay, now simple using this 0.11 means what? If you just look at the 0.11 means this table and this means C3 and 6, 3 and 6. Just see this 3 and 6 values, 3 and 6. This one is the closest one among all the data. So first using this we make a cluster and all this is just cluster 1. Okay, now after making this cluster we have to find out what is the next smallest value. So just look up this. Now if you look this, the next smallest value one is 0.44. Just next smallest one is 0.14 means 5 and 2. 5 and 2. By simple using these 5 and 2, we make the next cluster C2. We make this cluster. This is the C2. C2. And this one is the C1. Now next, let's see what is the next smallest value. Next smallest value is 0.15. Just say this thing, different color. 0.15. 0.15 for what? 3 and 2. 3 and 2 simply using 3 and 2. This is the 5 and 2. Now 3 and 2. 3 and 2 means which point? 3 and 2. The third point, which one? This one, using this one. Now the main things come into our picture. 3 and 2 is the now next smallest one, but 3 and 2 are already merged in the cluster 1 and cluster 2. If you consider the mean value, so among all the data, so these are the mean value between these two clusters. These are the mean value. Now simple, since this is the mean value, now instead of making this is a single cluster, we will make here this this one will be a single cluster. C1 and C2 are merged together, make a big cluster C3. Okay, I think you understand. This will be a cluster 3 C3. This will be the C3. This I'm using this. Okay, these will be the. Now what will be the next smallest value? Just see the look up on the table. What will be the next smallest value? 0.5. After 0.5, after 0.5, the next smallest one is what is? Search on your table. I think this is the 20. 20. The 20 what is? 20 means 4 and 2. 4 and 2. Okay. Okay. 4 and 2. This is the smallest one. 20, I think. Just see yourself. 4 and 20. 4, 2 and 4 means 2 and 4. 20. Okay, 20 means 2 and 4, but 2 is already picked up in the cluster C3 in the previous stage. So just say this distance. Now based on this distance, based on this minimum distance, we'll conclude, we'll make this is the whole cluster C4. We'll make this is now the single. This is now C4. Okay. Now after which one the smallest one? Just see this. Which one is the smallest one? After 20, I think it is 22. 22. Okay. See 4 and 6. 4 and 6 is the smallest one. 4 and 6. Now the same things already we have taken, so don't be confused. Now next the same things also. So just checking the smallest one. Okay. So first the thing we have merged together for C1. Just see these things. Just say things. For C, calculating the C1, we merged 3 and 6. For calculating the C2, we merged 5 and 2. You can see this 5 and 2. To calculated the C3, we merged C2 and C1. This is the C3. This is the C3. Now to calculated the C4, we merged C3 and C4. C3 and C4 we merged. This is the sample C4. This is the C4. Now after at the end of our iterations, we merged C1 and C4. C1 and C4. C5. I am denoting this through it. We merge this thing. The whole cluster. Now the C5. I think you got the point. How we will use this proximity value to calculate it, the edge cluster, and also the dendrogram. I think you got. This is the C5. I think you got it from this example. Now let's see what its range. What kind of range it has. Let's see it. So the range of it. The range it can handle the non-elliptical type structures. It can handle non-elliptical type structure. Just see this picture. In these pictures, there are two type of non-elliptical hands by simply using the mean concept. By simply using the mean concept, and they can easily separate it. This is the one cluster, and this is the another cluster. But these things in K-means, if you just remember the K-means, in K-means we have seen the different sizes of the structures are held by simply using the K-means or K-means plus plus. But by simply using the hierarchical clustering, the strength method means the hierarchical clustering, this mean method, if you use that, it is the easily handle this kind. This is the first kind of strength of this mean technique. And also there are some limitations. The limitations is the sensitivity to the noise and outlier. And the one thing that we have to remember here, already we have seen that this kind of non-convex type of structures in the K-means, but K-means are failed to give its clustering. What kind of cluster it is? This is the non-convex. But if we use this mean technique here, it is easily separable. It is easily separable. It's simple using this mean technique. We can easily doing this. Okay, this is the one type of advantage of the mean. But also there have some limitations. Just the limitations is the main limitation is the sensitive to noise or outliers. This is the main limitations of it. It is the sensitive. It is the sensitive to our noise or outlier type of data points. Just see these pictures. In this data picture, if you just closely see, these are the outliers of our data. These are the outliers. Just see this. These are the outliers of our data. These are the outliers. Okay, just considering the outlier after applying this mean technique, these techniques are make this is a cluster, this is a clusters, and make this is another cluster. Hence they cannot separate the whole cluster in the outlier. They also consider the outlier as a cluster point. Okay, this is the main drawbacks of this technique. Here you cannot separate it. Just see this thing. Okay, this is the main kind of drawback of this limitation. Now let's see this thing in the max technique, max method. Let's see that the same things also applicable here, max method. The first we have to, in the max method, we have to first find the what is the max value. what is the max value among it. So the first thing we have to find the maximum one. So the maximum one is what? Just see, find it from this table. Find it from this table. What is the maximum distance from this? Just see this. I think 0.39. 5 and 6. 5 and 6 are the maximum one. I think this one is the 0.39, means 5 and 6. The maximum one, maximum distance. Now, first thing that we have to make, it's a single cluster, right? Including this, using these distances. It's just see the max's distance. See the max formula here. If you just see the max formula is we have to find the proximity value, means similarity value, and to find the maximum one. The maximum one, in the maximum point, we have to make the one point is a cluster and the another point is another cluster. So here we will see that. Here we will see that the maximum value is what? Just see this. If you just okay. Maximum value is what? Maximum value is 0.39, means I'm taking this one. 5 and 6. Means here 5 is a single cluster and 6 itself is a single cluster now. Make it is a single cluster, it is a single cluster. Instead using this. Now after the 39, what is the maximum value on this? Just see it here. Maximum one is, I think 37. Just see it closely. 37 is the next maximum one. 37 is the next maximum one. Means 1 and I think 1 and 4. 1 and 4. 1 and 4. 1 and 4. Now first we make this is a cluster. Now first we have make this is a cluster. Just see the 5 and 6. 5 and 6 we make it. First this is a cluster using these distances, and this is the cluster C2. This is the one cluster. Okay, based on the simple concept of the maximum one, hence we have merged it. C1 and C2 means 5, 2 and 5. This one C2. After the next maximum value is this one. The next maximum value is this one. So using this 1 and 4. 1 and 4. This one is the one. So that we will merge these things into one cluster, because this one, because this is the next maximum distance. Now we will merge this is into a one cluster, and we will merge this into a one cluster. Okay, this is the sample C3. This is the sample C3 is merged now. C3 is merged now simply using the 1 and 3. 1 and 3 C4. This is our C3 and 1, 2, 5 and 1 are now is merged into the C4. Now at the end of the, what is the next max value? Now next to the next max value, just find it from here. The next max value 3, 4. 3, 4 is the next max value. 3, 4 value. Now based on 3, 4, it is the 1 and 5. 1 and 5. But 1 is already taken up into this cluster C4. 1 is already taken into C4, 1 and 5. So this cluster have been already taken, and rest of the is means C4 has already taken, and it is the another cluster. Just now if we merge these things into C4, this is into a C5 cluster. Just that means the concept behind the maximum technique is, if you just write the see this picture very closely, then you will understand the concept. Means the complete picture that you have to take. Okay, so first that the maximum value is what? Maximum value is 5 and 6. This is the maximum one value. This is the maximum value. Now among all the similarity value, we have to choose the maximum one, and this is the proximity value. Okay, this is the proximity value. Now first thing that we have to make the 5 and 6 will make a whole cluster. 5 and 6. This is the Okay, main whole cluster. Now next largest value is 1. What? Next largest value is 3 sevens. 3 7. 3 sevens means 1 and 4. Now see 1 and 4. Now based on these two value, we have to find what will be the next cluster. This one and this one. You just pause this video and try using these tables and using this formula that we have calculated here. Using this formula, just compute, just try to build this cluster. Okay, this cluster, just try to build this cluster. Okay, so this is the sample. This is the and another language. This concept are called the single concept. Single, it is the single. This is the single concept. First using the single point, and we have to march one by one into it. This is the single concept, and in max case we have to consider the complete one. We have to complete the complete one. Then we have to split it. It is the complete one. We have to consider the complete one. Then after we have to split it. It is the single one, and we have to march it. Here the main concept is single and march it. Here the complete one. Here we have to split it. These are the main. In max we have to first, this is the 5 6, just taken the complete one. This is a one cluster. Now using the second distances mean 3 7, we have to consider here. 3 7 means 1 and 4. Now we have to subtract it. This is the 1, so this will make a one cluster, and 4, this will make the another. Now single cluster are splitting into 2 cluster based on this. Now what will be the next value? 3 4 5 and 6. 5 and 6. Let's see. 5 means 1 and 5. Sorry, 1 and 5. 1 1 1 1 and 5. 1 and 5. Now this will be one cluster. This will be one cluster. This will be one cluster. And already it is make another cluster. Now next largest value is what? Now next, after 3 and 4, the next largest value is what? Let's try to find it. 3 4, after 3 4, I think 2 8. 2 8, I think. 2 9. 2 9 they have. There have 2 9 value also there. 2 9 means 4 and 5. 4 and 5. Now based on the 4 and 5, 4 and 5. This is one cluster and this is another. Already it is taken, so don't be confused. Now next smallest value, next largest value is what? After 2 9, next smallest value is 2 8. Means 5 and 3. 5 and 3. 5 point is what? 5 and 3. So this will be make one cluster, this will be make one. Means we have to first take the complete one. Now based on this value, we have to split the complete one and make the smaller one. This is the concept behind the maximum, and behind the minimum. The concept is we have to consider the single one as a cluster. Now based on the minimum value, we have to merge the single cluster into the bigger cluster. Means we have to make smaller to bigger. We have to make the concept easy. We have to make smaller to bigger based on minimum value. Here the concept is for maximum, or the concept is for bigger to smaller. Bigger to smaller based on maximum value. This is the main concept behind this story. And the strength of this is that the strength that it is less susceptible to the noise as well as outlier. This is the less susceptible. Using the, just say this thing. So if you use a maximum method, then the clusters are easily separate. These two type of. These are the one cluster, it is separated. These are the one cluster. These kind of outliers are okay. These are the another cluster. It is well separated. Okay, this is the main strength. And also there have some limitations. The limitations are it tends to break the large cluster into smaller one. Okay, based on the globular cluster. Globular, that is the main definitions of the globular. This is come from the this globular concept is come from the globe from the mentions of the globe like cluster. This is the come from the globe like cluster. Okay, just see these things. This one is a bigger cluster and this is the smaller cluster. This one is the bigger cluster and this is the smaller cluster. But if we use the maximum concept here, so these things will make a single cluster. These things make a single cluster and this one will be make another cluster. So it is not that one. Okay, let's say these things. So for the bigger cluster, for larger cluster, this is the main drawback. For larger cluster, these methods fails to make this cluster. Okay, this is the main limitations of the maximum method. Okay, now they have the third type of cluster. This is the group average. Simple, the same things also applicable here. Here we have to make the average distances here. Just see the average distances between the two edge clusters, 1 and 2. The same things also applicable. Just here I have taken the concept of the maximum. Here we will use the concept of the average one, average concept. The average concept formula already we have taken from here. This proximity value, just see this formula. Just see this. Just see this formula you have to choose, this proximity value you have to took, and we have to make the clusters between C1 and C2. We have to find its average value. By simple using the average value, we can easily find this kind of pictures. And sometimes these pictures are called the group average picture. Okay. So this is the group average technique that we will use to build this kind of this other nested cluster. This is the dendrogram. Just pause this video and try to make this cluster in units by simply using this proximity value. Okay, so let's see what is its strength and what is the limitations behind these structures. So if you just comparisons between the previous two, one single and the complete link, means just see, this is called the complete link, this is called the single link, this is called the single link cluster. So the advantage is here, it's the compromises between the single and complete link. Means it's the middle one between these two type of cluster. If this one is the mean one, if this one is the max one, then the average one, like this, compromise these two between these two. Okay, the strength is it is the less susceptible to the noise and outliers. That's already we have seen in the advantage of the max one. So this is also its one of the strength. It is the less susceptible to noise and outlier. And the limitations is biased towards the globular cluster. So it's cannot separate it to different kind of globular clusters. Okay, this is its one type of limitations. Okay, it's the limitation, one kind of limitation, globular cluster. Okay, this is the main strength and limitations of these group averages. Now they have one type of another kind of clustering technique, that is the Watts method, that we have called Watts method. So the simple Watts method is the same type of, but they have difference to the average. Means in averages, just if you remember, in averages we have used the distances between the points. Okay, in group averages, just if you remember, we have taken here the group average, we have taken here the distance between the points, distances between the points. but here we will use the distances, square distances. Instead of using the distances between the point, we will use here the squared distances. Now let's see how this formula, or if you use the words method, how this formula will actually look like. Okay, let's see. So if we use the words method, then the value, similarity value, means here we have used the distance value between the two clusters U1 C2 are now look like this type. Means distance of the point Pi and Pj, we have to take it square, make it summation square. For Pi will be the cluster 1 and Pj value it will be like on the cluster 2. And in denominator we have to take the length, size of the edge cluster. This is the same formula that we have seen in the that we have already seen in the averages cases. But instead of using this similarity value, we are using the distances value. Distances square means just we are using, because why we have distances square, just we have used things by simply using the square error to increase the square error, how much error they have. Simple to denote this, we have used this square error. Okay, we are using this square, we will use this distance square. I think you will understand how these things are actually work. Okay, now there have these the 4 types of comparison side by side that in previous discussion, previous discussions we have seen. These are the complete, these are the mean technique. This means that using simple means formula, the picture that we got, using the max formula with this type of pictures we got, using the group average formula we got this type of clusters, and using the oldest method we will got this type of pictures. These are the differences, this is the comparison side by side between the edge methods. Okay, and in different situations different methods are useful, and edge methods also there have some limitations, so we will take care about it. So based on our problem, what kind of problem we have, and based on these problems we have to choose the right, what will be the right one. So from these discussions we will see what kind of limitations and what kind of advantage they are have in each methods. Also, as always, they have some limitations and some they have some strength, but we have to take care about it. As our problem, as our requirement, we have to select the best one that is our targeted. So when we discuss the case study, when we discuss the one project, one will discuss the projects, various kind of projects using machine learning, using this kind of techniques, then we will see in which situations which kind of technique is useful, then we'll see these things. I think from this lecture you will got the idea how to calculate the various kind of proximity value by using various kind of proximity methods, and what its advantage and what kind of limitations it have. I think you got the idea. I request you, if you feel bored, please pause it and take a break. After the break, you just revisit this lecture. And just if you feel, if you means I am talking about, if you don't understand anything, please comment below, or just mail me. Okay, I will try to give you the explanation as possible, as simple. Okay, as simple as possible as I can, I will try to give you. I request you, if you till now if you don't understand this thing, please pause this video and try to think yourself one by one. Just see this mean part first and try to visualize these things to yourselves, through your visualizations. Okay, just see this mathematical formula and take this data. Okay, and using this mathematical formula try to build yourself in your own copy. Just take this data, just take this matrix data and try to build this in your own, in yourself, just using this formula. Okay, similarly for max one, similarly for group average one, I request you please do that in yourself as a homework. I think then this method will be more clearer. Yeah? So we will see the next concept in the next video.